Hello and welcome to Mitsubishi Electric Webinars. My name is John Harity, and I work within the marketing group here at MEAU. The following Application Solutions webinar will cover rotary knife applications in the packaging industry, where we will take a look at how Mitsubishi Electric's factory automation products can be used to create a powerful solution. Before introducing Mitsubishi's product solution, I'd like to touch briefly on the basics of an industrial rotary knife application utilizing servo control. In order for the servo system to cut constant length material, it must be configured to track and respond intelligently to the line speed of the moving material. Here, a master encoder is connected to the lower steel cylinder to provide a reference for the servo to follow. The quadrature AB phase incremental encoder is connected or geared to the conveyor or the VFD axis located beneath the servo knife. The servo acts as a follower or slave servo axis that responds to fluctuations in the counts per second from the encoder. A mark sensor or photo eye tracks the material as it passes by to correct the servo if the paper bunches up or stretches unnecessarily. Another sensor can be connected to the slave servo for registration or homing purposes. And finally, you have the HMI to input parameter information and to monitor the machine's performance. Example applications for rotary knife machines include paper and metal cutting, perforation, stamping, flat material sealing, wood cutting, and labeling. The solution provided by Mitsubishi Electric includes two main product groups, the servo and motion controllers and the HMI graphic operation terminals. Through the free servo sizing software from Mitsubishi Electric, the speed, torque, and load inertia characteristics of the system are used to determine which motor is best fitted for the application. Mitsubishi's low inertia, high-speed HFJP motors provide a good fit for this particular application. An MRJ3B safety amplifier is connected to the MRMQ100 single-axis motion controller via Mitsubishi's fiber optic servo network, SSCnet 3. This servo network provides extremely fast refresh times for position data from the motor and is processed every 0.44 milliseconds. Additionally, a GT12 series or GT10 series HMI is connected to the MRMQ100 controller for system operation, monitoring, and for troubleshooting. Mitsubishi Electric products provide several advantages and benefits to end users for rotary knife applications. First of all, Mitsubishi's visual programming environment provides an extremely flexible configuration of the system for easy facilitation within sequential function chart programming. This reduces the development time up to 30%, which results in reduced labor cost. Through the mechanical editor's visual programming environment, an electronic cam is used to change the speed of the rotary knife axis. Electronic camming reduces the machine cost due to fewer mechanical components. The next highlight includes the MRMQ100's high-speed mark registration capability. With 4 inputs built into the controller, the machine productivity is increased. With a mark registration function enabled, the product length can be kept very consistent, resulting in higher quality production and less wasted material, ultimately saving money for the customer. Mitsubishi Electric's single-axis motion controller's built-in Ethernet communication can be used to connect up to 16 third-party devices, providing automatic IP detection to further reduce machine setup time. Additionally, customers save cost with standard high-speed Ethernet cabling. Program upload and download times are also very fast for less hassles during development and machine installation. Let's take a closer look at the control system to understand how each component is connected to the MRMQ100 single-axis motion controller. The MRMQ100 is one of the most compact motion controllers in the world, with an extremely narrow face width and 4 ports on the front side. The controller can be directly mounted to an MRJ3B safety amplifier. A 50-pin I/O port on the front is used to connect the incremental encoder and mark sensors. This provides direct access to the motion CPU for accurate processing and can also be used for an RS-422 connection to a GT10 series HMI. The port on the bottom provides 24-volt DC power to the CPU from an external power supply. Sandwiched in the middle of the controller is a fiber optic port for connection to the servo amplifier and motor. The Ethernet port at the top is used for program upload and download from a PC, as well as for a connection to an Ethernet-based HMI. Note that there is also an option to add an MRJ3D01 card to the servo amplifier for additional digital and analog I/O control. One of the main requirements for a rotary knife control system is the need to match the speed of the moving material while the servo blade penetrates the material it's cutting. Depending on the type of material, the cutter blade may actually need to enter the material at a slightly faster speed. The trickier part to the programming, which has already been created for you, is coming up with how much speed needs to be added or subtracted depending on the length requirement for the product. For a shorter length, the knife needs to speed up during the non-cutting region. This can be done with a sinusoidal cam profile or through a direct speed increase as shown in the figure here. You'll see that after the knife cuts the material, since the circumference of the rotary cutter is longer than the product length, the servo must speed up in order to be in the right location in time for the next cut. In the opposite case, if the product length is considerably longer than the servo's circumference, the servo must slow down relative to the line speed of the material. This can be viewed as a move in the opposite direction to the already imposed movement from the encoder following. Mitsubishi Electric's visual programming environment for a rotary knife application helps to save a considerable amount of time during development. The visual layout can also be monitored on a PC for easier troubleshooting. The layout shown here provides a great amount of flexibility for controlling a rotary knife system. The incremental encoder is connected as the drive module in the virtual layout. The encoder passes positional information through a spindle gear through the electronic virtual clutch. This electronic virtual clutch remains closed, which means that the servo axis always responds to movement from the encoder. The master encoder's data is then transmitted through a differential gear to the electronic cam. This output module represents the rotary knife servo axis, and it provides the flexibility to change the stroke setting if necessary, or to create custom cam profiles. In this example, a feed cam is used to provide one-to-one follow with the encoder. The electronic virtual auxiliary servo motor on the bottom left provides speed correction and distance compensation through the non-cut region. This virtual motor is engaged as needed during operation.